In this video, we are going to look at two examples of finding the equation of an exponential graph. Now, before we look at the first example, I just want to remind you that the equation of the exponential graph is y equals a times b to the x plus p plus q. Okay, now in the standard form equation, there are 1, 2, 3, 4 parameters. Okay, now in our school maths, you will never be asked to find or solve for more than 2 of those parameters. So when you are asked to find the equation of an exponential graph, you will be given part of the equation. So look carefully at what you are given and then solve for what you don't yet know. Okay, so in example 1, it says consider the graph of y equals b to the x plus q. Determine the values of b and q. Now, if we look at this equation, we are actually given the value of a. A is the invisible 1. And the value of p, because nothing is added or subtracted to x, p is 0. Okay, right. Now, from your exponential, your graph, q can always be known by the value of the asymptote. Okay, so in this graph, y equals -4 is the asymptote, so q will be -4. So we have that q equals -4. Okay, so we've already answered part of the question there. But now to solve for b, I'm going to substitute the q into the equation. So I have y equals b to the x minus 4. Now I need to solve for b. If I have one variable to solve for, I substitute 1 point. So I actually write substitute, letting my reader know what I'm doing. Okay, so y is 4, so I have 4 equals b to the x is now 3 minus 4. And I need to solve this for b. Now, this is an exponential equation where the base is the unknown. Okay, so we're going to add, we're isolating the power there. So I'm going to add 4. So 4 plus 4 is 8 equals b cubed. Now, there are two ways in which you could solve this. You could prime factorize the 8, and it would give you 2 cubed equals b cubed. The exponents are equal, so you could equate the bases. Okay, or you could just cube root on both sides. So or you could just cube root on both sides. So I have b equals the cube root of 8, which is 2. Okay, so b is 2 is our other value that we had to find. So we had to find the values of b and q. I've answered that question. Okay, now often a subsequent question will require you to use the equation. So just for your own sake, always just write out the actual equation. So b is 2, so it's 2 to the x minus 4 as our final equation. Looking at a second example, here we are asked to determine the equation of g of x equals b to the x plus 1 plus q. Okay, again here we are given the value of a. It's 1 again. Now it won't always be 1, okay, just in these two examples. P is 1, and we don't know the value of b, and we don't know the value of q. Okay, now again, our asymptote gives us the value for q. So the asymptote here is y equals -2, so therefore q equals -2. And I can substitute that into the equation. So I have g of x equals b to the x plus 1, and q is now -2. Now I have one unknown, which is the b, so I substitute 1 point. So one set of coordinates, and it will be -3, 2, which is the point that we were given on the equation, on the graph. So y is 2, and b is -3. So I have b to the x is -3. So y is 2 equals b to the -3. So x is -3. I'm adding 1 to that, minus 2. Okay. So I need to solve for b, so I need to isolate the term with the b. So I'm going to add 2, so I have 4 equals b to the negative 3 plus 1 gives me negative 2. Okay, now remember that a base to a negative exponent can be written as a fraction with a positive exponent. Okay, so this is 4 equals 1 over b squared. Equation with a fraction. Okay, you can multiply by the denominator, so we have 4b squared equals 1. We want to isolate the b squared, so divide by 4. So I have b squared equals a quarter. Now, this is a quadratic equation because I have my variable being squared. So I can square root to solve for b, but I need to remember that a quadratic equation always has two solutions. So it will be plus or minus the square root of a quarter, which is plus or minus a half. Okay, so this gives us two values for b. That would give us two equations. Okay, but we only have one graph. So one of them does not count. And we need to remember that for an exponential graph, exponential function, b had restrictions on it. We were told that b had to be positive and b cannot equal 1. So we need to reject the negative value for b here. So we write, but b is positive and therefore b is equal to a half. And yes, you must show this in your working. Okay, so our final equation then is g of x equals, now, your base. If your base is a fraction, it is very important to put the brackets around that. Okay, our exponent is x plus 1 and q was negative 2. I just want to tell you that if you don't write the brackets, and we have this, then this exponent applies only to the 1. It's saying that the base is 1 and everything is over the denominator 2, which is a very different graph. Okay, so if your base is a fraction, you must put the brackets around it. But that is our final equation.